If you are still using bcrypt for new projects in 2026, you're behind. Not wrong, but behind. Today, I will show you how to implement Argon2 ID, the current OWASP recommended standard in your Node.js application. If you care about security, you might want to check this out. Quick history lesson. Bcrypt was designed in 1999 against CPU attacks. Nowadays, attackers usually use GPUs or ASICs. Argon2 was created to win the password hashing competition in 2015 by being memory hard and resistant to these modern day attacks. So we are not talking about moving plain text to hashing, we talk about upgrading the hashing algorithm itself. Argon2 has three flavors. Argon2i resists side-channel attacks. In a nutshell, these are attacks where hackers don't break the system but learn secrets by observing timing, power usage, and behavior. Argon2d resists GPU cracking. Basically, these are attacks where hackers use massively parallel GPUs to try billions of password guesses, but Argon2d makes each guess memory hard and unpredictable, so GPUs lose their speed advantage and cracking becomes expensive and slow. And finally, Argon2 ID is the best of both worlds, that's why it's explicitly recommended by OWASP. That's our goal today, modern password security. Enough talking, let's go to VS Code and check this out in action. I already prepared the code for this tutorial, but first we have to install the Argon2 npm package, so let's go in the terminal npm I argon2. Okay, let's close the terminal for now, and I'm gonna walk you through this function. So first, I import obviously the Argon2 npm package. I created a new password variable. This is just a demo password. In a real application, this password would come from a user input. Now Argon2 functions are async, so we wrap everything into an async function. This lets us use await without setting up an entire application. First, we pass the plain password into argon2.hash and it returns a secure hash. This is the value you store in your database. As you can see, I also added some options for this hashing. Now these options control how expensive the hashing operation is. I don't want to go too deep on these options because it would need a longer video to explain everything in depth, but in a nutshell, memory cost is for how much memory hashing uses, time cost is for how many iterations the hashing uses, and parallelism is for how many CPU cores are used. Let's just say for most apps the defaults are already safe. I'm just showing you this so you know it's configurable. Let's run our function and check out how the hash looks like. So in the terminal, go node index.ts, and before I do that, I console log this one out so we only see the hash. Now the hash itself looks really interesting. So first we can see which algorithm we used. So in this case, it's Argon2 ID. After that, we can see this v equals 19, which means the version of Argon2. This is the current stable version, and this ensures compatibility in the future, so even years later Argon2 knows how to verify this hash. After that, we see our security parameters we set in our options, so the memory cost, the time cost, and parallelism. So the settings are embedded in the hash itself. After that comes the salt, and this is a random value. It's different every time, so it prevents rainbow table attacks. And this is why the hash is different in every run. And after that, it comes obviously the actual password hash that can only be verified and not reversed. Let's run our hashing again so you can see that it's actually generating another one. Here you can see that our parameters in the beginning of the hash are the same as before, but the salt is different and the hash is different as well. Great. Now let's check our verification function. To verify a password, we pass the stored hash and the plain password into Argon2.verify function. The Argon2 extracts the salt and the parameters from the hash and then makes the verification. If the password matches, it will return true. If it doesn't, it's false. So let's comment out this console log here and run our app again. And you can see that the password was valid since we passed in our correct hash and the correct password. Now let's make a test run with the wrong password. So do this. And now our password verification is false. In a real application, you would hash the password when a new user registers and store it in your database. Then when the user logs in, you would verify the password exactly like this. So this is the core of secure password handling in Node.js with Argon2. Once you understand this, building authentication becomes much simpler. I hope you liked this video. Catch you in the next one.